Large language models are powerful, but alone, they are not enough. Let's break it down in simple terms. Think of them like a brilliant mind, just kind of floating there with no way to actually do anything in the world. Well, today, we're talking about the thing that acts like a nervous system, connecting that mind to reality. And that thing is LangChain. All right, so here's what we've got on tap. First, we're going to cover exactly what LangChain is. Then, we'll get into why it matters so much. After that, we'll look at how it actually works, check out some real-world use cases, and I'll even point out a few beginner mistakes to avoid. And of course, we'll wrap it all up with a quick recap. Sound good? Let's go. Okay, first up, what is LangChain? People call it the orchestration engine for AI, and that's a pretty good place to start.
So if you look at the official definition, LangChain is an open source framework for building apps that are powered by LLMs. But what does that really mean? Well, think of it this way. LangChain itself isn't the AI. It's the essential glue. It's the toolkit that lets you connect a powerful model, like a GPT-4, to all the stuff it can't normally reach, like your company's private documents, real-time data from the internet, or other software tools. It's what turns a cool demo into a real, useful application.
You know, here's probably the best analogy I've heard for it. If an LLM is the brain, then LangChain is the nervous system. Seriously, picture an incredibly smart brain just sitting in a jar. It knows a ton, but it's totally cut off from everything. LangChain is what gives that brain senses, the ability to see your private data or look at the live internet. And it gives it limbs, the tools it needs like calculators or APIs to actually do stuff in the real world. All right, section 2. Why does any of this matter? Well, it's all about solving the LLM's biggest problems. To really get why LangChain is such a huge deal, you first have to understand the major limitations of a large language model when it's just by itself. Okay, look at this comparison. On its own, an LLM is basically a static brain. Its knowledge is frozen at the time it was trained, right? It has zero long-term memory of your past conversations, and it can't access any new data, let alone your private files. It's powerful, for sure, but it's also kind of passive. But when you bring LangChain into the picture, everything changes. It becomes a connected, dynamic system. Suddenly, it can remember past chats, it can tap into your specific data, and it can use tools to actually take action in the world. Let me put it this way. Let's say you want to build what sounds like a simple app, a chat with your PDF tool. Easy enough, right? Wrong. Under the hood, it is a massive engineering headache. You've got to load the document, split it up into chunks, create something called embeddings, which are just fancy numerical representations of your text. Then you have to store all that in a special kind of database called a vector database, and then you have to figure out how to retrieve the right information when a user asks a question. I mean, just building all that plumbing from scratch is a ton of work. And that exact pain point, that's what LangChain was built to eliminate. So, how in the world does LangChain handle all that complexity so well? The answer is actually pretty elegant and surprisingly simple. It all comes down to something called chains. A chain is really just what it sounds like, a sequence of steps linked together. At its simplest, you might have a prompt, which you pipe into the language model, and then you pipe the model's output into a parser to format it nicely. See how that works? The output of one step just flows right into the next one as its input. This super intuitive pipe syntax, they call it the LangChain Expression Language, or LCL for short, is what makes it so easy for developers to build these really complex workflows just by snapping different pieces together. And to build these chains, LangChain basically hands you a full toolbox of components. You get standard interfaces for all the major models, OpenAI, Anthropic, Google, you name it, so you can switch between them with like one line of code. You get tools for indexing all your data, that whole loading and splitting process we talked about. There are components for giving your app a memory so it remembers what you talked about before. And then there's the really cool part, agents. This is where you let the LLM itself act as a reasoning engine to figure out which tools it needs to use to get a job done. It's a whole ecosystem, really.
Okay, moving on. Let's talk about the fun stuff. What can you actually build with all this? We're talking everything from chatbots to full-blown AI agents.
Probably the #1 use case people start with is building knowledge assistants. This uses a fancy-sounding technique called retrieval augmented generation, or just RAG for short. And this is exactly that chat with your PDF idea we mentioned earlier. You can build a chatbot that answers questions using your company's internal wiki, or maybe your customer support tickets. You're basically making the LLM an expert on your specific private data, which is a total game changer.
But RAG is just the starting line. The next level up, that's AI agents. And honestly, the best way to think of these is as chatbots on steroids. They don't just talk to you, they use tools to actually do things. Imagine giving an agent access to your calendar, a flight booking website, and your email, and just telling it, hey, find the cheapest flight to New York for next Tuesday and book it for me. The agent has the reasoning power and the tools to go out and make that happen. It's pretty wild.
All right, before you get too excited and dive right in, let's talk about a few common mistakes that beginners often make. Trust me, avoiding these is going to save you a whole lot of headaches down the road. Okay, mistake number 1, thinking LangChain is the AI. It's not. Remember, it's the plumbing, not the brain. It's the orchestrator. Second big mistake is reinventing the wheel. LangChain gives you all these pre-built components for a reason, so use them. There's no need to build a text splitter from scratch. And finally, don't worry about getting locked into one model provider. One of the best things about LangChain is that it's model agnostic. That means you're not stuck with OpenAI forever. If a new, better model comes along from Google or Anthropic, you can swap it in, sometimes just by changing a single line of code. That's a huge advantage.
By the way, if this is making sense so far, do me a favor and give this explainer a quick like. It really helps out.
Okay, we've covered a lot of ground. Let's do a final recap and lock in everything we've learned. Think of this as your LangChain cheat code.
So if you remember anything, remember this. 1. The problem is that LLMs, by themselves, are powerful but totally isolated. 2. The solution is LangChain. It's the framework that connects them to data, to memory, and to tools. And 3. How does it do it? It uses those chains and a whole library of pre-built components to make building complex AI apps way, way simpler.
So now you've got the fundamentals down. But what's next? Well, in the next explainer, we're going to take it a step further. We'll see exactly how LangChain is used to build those real AI agents we talked about, the ones that can actually do things for you. If you like this content and you learned something from us, please subscribe to this channel for more updates like this, and share this on all your social networks.